So, good morning, everyone. Am I audible? I think I'm audible. Everything is all right. Am I audible to everyone? Okay, thank you. I got a response. See, dear children, yesterday we were discussing about static electricity. Static electricity means the charges at rest, the effects and impacts of the charges at rest. Today we are going to see charges in motion. Charges in motion means electric charge flowing from one point to another point. The flow of charges constitute a current. And what are the effects, impacts, and what are the different applications of this moving charges, that is current, that we are going to see today. The chapter is titled Current Electricity. In this chapter, compared to previous years, a few topics are deleted, and we must be very careful in dealing with this chapter. We need to study only the chapters which are included for the examination. So let us see what are these topics. First one is electric current. You must understand what is basically electric current. Then the flow of electric charges in a metallic conductor. Then the drift velocity, mobility, and the relation with electric current. Then Ohm's law in detail, applications of Ohm's law, limitations of Ohm's law, the different characteristics of Ohm's law, VI characteristics. Of course, the linear and non-linear applications we have to see. Then electrical energy and power we have to deal, because we expect numerical problems from that area. Then electrical resistivity and conductivity. Remember, electrical resistance, it is not included in this section, in this chapter, because electrical resistance we have already studied in class 10. So obviously we must know what is electrical resistance. Children must be in a position to understand and apply the knowledge of electrical resistance, and that's why it is not included. Combination of resistance also. Okay, you must be in a position to apply the combination of resistance in this chapter. Then electrical resistivity and conductivity. Temperature dependence of resistance, how the resistance varies with temperature. Any increase in temperature is there, or any decrease in temperature is there. Is there any increase in resistance with respect to temperature is there, or is there any decrease in resistance with temperature is there, that we have to see. Then the internal resistance of a cell, then potential difference and EMF of a cell, combination of cells in series and parallel, Kirchhoff's rules, Wheatstone's bridge. See, these are the only included areas. There is no meter bridge, there is no potentiometer. Such things are deleted. Be very careful in dealing with this particular chapter. Now let's begin. Electric current. Basically, what is electric current? Many students say that it is nothing but the flow of charges. Of course, it is nothing but the flow of charges. See, we have a cell. Electrons will be flowing. Electrons will be flowing from negative terminal of the cell to the positive terminal of the cell. We all know that electrons are having negative charge. So the conventional direction of flow of current is taken as from positive terminal of the battery towards the negative terminal of the battery of the cell. So electric current is defined as the rate of flow of charges across a given area of cross section. See this one, I is the electric current. It is defined as Q divided by T. Q is the charge and T is the time. Q upon T. The charge flowing per second is called electric current. Rate of flow of net charge. Electric current is defined as the rate of flow of net charge flowing across a cross section in delta time, in a time interval of delta t. That is the definition of current. See, when we put it in the mathematical form, we write it as delta Q divided by delta t. Delta Q is the charge flowing and delta t is the time interval in which the charge is flowing. So that is the definition of current. So simply we write it as delta Q divided by delta T. The SI unit of current is ampere. We know all these things. Just refreshing it. Then in the case of a conductor, what are the properties of electric current? Electric charge in motion. It is due to the force experienced by an applied electric field. So electric field is applying the force and to set the charge in motion. Electric field is applying a force to set the charge in motion. That is the thing we have to remember. Now, in solid conductors, the current is carried by negatively charged electrons. What is the charge of electron? Charge of electron is 1.6 into 10 power minus 19 coulomb with a negative charge, negatively charged electrons. Then in the case of an electrolytic solution, the current is carried by the motion of positive and negative ions. Okay. So in the case of conductors, the current is carried by negatively charged electron. Each electron is having a charge of 1.6 into 10 power minus 19 coulomb. Whereas in the case of an electrolytic solution, the current is carried by motion of positive and negative ions. Positive ions are there as well as negative ions are there. Okay, when no electric field is applied, when in the absence of an electric field, the electrons are in random motion. Okay. So there may be a doubt that all the time the electrons are moving, then how a current is not present? So this is the answer to that question. Okay, when no electric field is applied, the electrons are in random motion, but that random motion, one second. What happened?